For a while now, there's been a consistent whine coming from the rear end of the Mustang. Here's what it sounds like.
That noise.
I think there's some bearings going bad. I crawled underneath the Mustang and gave the drive shaft by the pinion flange a wiggle. Sure enough, there's some play. There shouldn't be any lateral movement like that. With the rear wheels and brakes removed and the drive shaft disconnected from the flange, the pinion preload could be checked with a beam type torque wrench. The reading was less than 3 inch-pounds. For used bearings, the specs should be 8 to 14 inch-pounds. With little hope of this fix working, I went ahead and tightened the nut down to achieve the proper preload reading. There's little hope because the crush washer on the pinion shaft is most likely crushed too much, and the preload won't hold properly. With everything reinstalled, I took a test drive.
Didn't fix it.
Well, that didn't fix it, so I guess we'll have to do all the bearings now. Link down below. With the wheels, brakes, and drive shaft removed again, the differential cover can now be cracked and drained. The axle shafts are removed by pressing in and removing the C-clip that holds them inside the differential. There's a link in the corner to a video covering this in more detail. Next, the panhard bar needs to be removed so the center section can come out. There's 4 bolts in total, 2 for each of the bearing caps that hold the center section inside the housing. Once they are removed, the center section will come out with little effort, though it is heavy and awkward to do on your back. With the center section out, we can remove the pinion flange and remove the pinion from the housing. And now the real fun begins. All of the old bearings need to be removed. This bearing removal kit can be used instead of a hydraulic press. It's supposed to grab below the bearings and pull them off of their shafts. I was not having much luck getting this kit to work, so I went and borrowed a hydraulic press. The clamps from the bearing kit worked well when combined with the hydraulic press. When it wasn't slipping off the lip, that is. I kept the same pinion shim from the old bearing and used it with the new bearing. Ford makes a special tool to use to properly figure out the right shim to use. I don't have the tool to show that here, and since we're just swapping old parts for the same new parts, we most likely will not need a different shim. For the carrier bearings, the clamp tool I had was not going to work with the press for removal, but the little spinning air powered death wheel made for a good substitute. A little bit of hammer and chisel also helped free the old bearing from the race. Install was simple, just like the pinion. I really need to get me one of these air over hydraulic presses. Back to working on the differential housing. The old pinion bearing races need to be removed. But first, the pinion seal and outer bearing. Now a brass drift and hammer can tap out both the inner and outer old races, or use an air hammer. Use a bearing and seal driver tool to seat the new bearing races. The races need to be installed properly into the housing, otherwise our noise won't go away and the new bearings will wear prematurely. The pinion gets installed first, and the flange installed, torquing to a minimum of 140 foot-pounds, and achieving a preload of 16 to 28 inch-pounds for these new bearings. The carrier is next to go in, using the old shim spacers that came out with the carrier. We will take some measurements and check the wear pattern. We may have to change the spacer setup. Tighten the bearing cover bolts to 90 to 100 foot-pounds, then spin the carrier to make sure it turns freely. First, we need to check how much backlash there is between the ring gear and the pinion shaft. We measure at the edge of one of the ring gear teeth with the dial indicator. We're looking for it to be between 8 thousandths and 12 thousandths of an inch. My indicator was not mounted tight enough and the reading was jumping down the gauge, but we were getting around 13 thousandths of backlash, which is just out of spec. To correct this, the carrier needs to move in closer to the pinion gear. This is done by making the carrier spacer on the driver's side thicker and making the passenger side thinner. The new bearing kit came with a bunch of super thin shims, and we basically have to build 2 new spacers by stacking the shims. Use a micrometer to get the thickness of the old spacers, then use the shim chart to do the sum math and make new spacers. Install the new spacers and recheck the backlash. This may need to be done a couple times to get the backlash in spec. The last thing to check is the wear pattern between the ring gear and the pinion gear. Most new bearing kits will come with some sort of marking paint. We paint it onto both sides of 5 or 6 of the ring gear teeth, then rotate the whole assembly back and forth a few times. This lets us see where the wear pattern is. The goal is for the wear pattern to be in the center on both sides. If it is not centered, the side bearing spacers need to be changed or the pinion bearing shim needs to be changed. Changing the side bearings spacers is simpler as long as the backlash stays within spec. With everything reinstalled, take a test drive.
The noise is gone. Such a better ride now.
If you're planning to do this repair yourself, I highly recommend following the Ford 8.8 ring and pinion instruction sheet. Everything is properly described and every chart for measurements is in there.